Morning, guys. It's part two of the org chart series. We're going to try and build an org chart for React here, and because it doesn't seem like there's anything else there. And as a perfect example of sort of an org chart like tree flow or data structure, I chose to use classes with their prerequisites, and we can see kind of what an org chart looks like here. Um, an org chart's kind of like a top-down tree, and it shows relations of hierarchy. So like this record right here, the top is the uppermost record, and then these two kind of belong to it. In our case, for this example at least, we're using classes. So a class, maybe finance 480, would require finance 401 and 402, whereas 401 would require 400, maybe 402 requires, accounting 201 or whatever, and so on and so forth. So if you haven't seen part one of this series, go and check it out before you watch this one. Welcome back, guys. Let's do this. So if last episode, what we ended up doing was we took a tree of data, and the gist is in the description below. While you're down there, you might as well click subscribe if you like the content. And basically, it's this tree. So you've got a class. So say you send a request up for the class Finance 480, it's going to return to you the prerequisites, okay? Finance 303, 307, and 345. And also included are the prerequisites expanded, which includes the prerequisites. So you can build a tree this way. See how it's kind of, the tree keeps getting deeper and deeper here. It's like a recursive data structure. Like see, eventually you get down to honors 125, which requires honors 124. And we can see that now. What we've done is we've flattened this into a chart that we can use. That's right here. So I mean, it looks like our first semester we're going to have to take accounting 201 if we want to get anywhere. If we want to take finance 480. So we also have to take honors 124 if we want to take honors 125, which is what we need to take finance 301, which is what we need to take finance 345. So we got them flat, but we don't have them lined up nicely. Like we need to draw the lines in between these. And we get to think together about how to do this because I am not totally sure. This is a weird problem. So let's go to, we kind of did it up in numbers over here. This is kind of a basic flow. It's not our exact one. We have 307, 303, 345. Each of these actually need 301 is what it ended up being. Oops, we'll do find 301. So each of these top three classes need finance 301. Finance 480 is our topmost class. These are the first set of prerequisites. The next set, and then we've got accounting. Each of these ones, I think they take, it's the same class, Finance 301. And each time that's going to take accounting 201, honors 125. Accounting 202 and honors 125. Now we have to do that for each of these, so we're going to have to like shift our table here by a bit. I don't know if that's exactly the right amount, but ideally this would go in the center of that, and then we would have another set of these three here, and another set of these three, centering the uppermost tiers above the place where they belong in the org chart, I guess. So that you can tell that these three classes are required to take Finance 301, and Finance 301 is required to take Finance 307. And we have one more row in our example here. And so, what is it? I think to take 202, you have to take 201. And so even though Finance 301 requires Accounting 202, it also requires 201. But 201 or 202 requires 201 anyways. Let's see. And then Honors 125 requires Honors 124. So let's 124, and this one takes Accounting 201. And we can repeat that for each of our, in this case, each of our little branches here, 201, Honors 124. So this is our tree structure, sort of. This this should ideally be, I guess, above the middle here. Still trying to figure that out. So if you can see, this is kind of our tree. Like we could put a line here, a line here. Oops, not there. There. Let's see. So we need to be able to draw lines now. And yeah, like really, we need to draw lines from the parents to the children. And we need to line these up. So I think we can start by, if we can determine the number of elements in a row, I wonder if we can make that into the sort of control row. And then create our grid off of the maximum number of elements. So see how this row 3 here has 1, 2, 3. It's got 9 classes in it. So what if we made that into the grid then? What if we made this whole thing a grid of 9? And then each of these could take 3 of the 9, since there's 3 of them. These ones would do the same, take 3 of 9. And these could each take 1.5 doesn't really work, does it? I guess 2 of them, for every 2 they would take up 3 cells because they're parent cells. Or maybe we just put them right under where they should be. I guess we'll just start. Let's start at the top. So we're gonna go to wherever we find our row 0, or where we create our row 0. And that's right here, or row 1, I guess we call it. Maybe we just need to find, yeah, let's start by tagging out how many items are in the rows. So we've done the convert prerequisite to tree rows. Let's do convert max length equals, and then what we'll do is we'll go through and we'll filter this row actually, I think we want to structure these rows. I think we need to add some kind of metadata to the rows. I think we need to add, let's see, so a row Right now it's just an array of courses. I think we want a row to be an array of courses, or an object that has an array called courses instead. And then you would do row.courses.find course. Yeah, so then if any of the courses in the row have any prerequisites, you keep going. And then you return, yes, maybe. Let's see, so a row would be courses. All right, and then to use this data, it's a little different. So we're passing in rows, that's all good. We go to our org chart. Our org chart, we need to map row.courses to each node. And let's see if that compiles. We broke it, that's okay. Let's see, prerequisites expanded of undefined. If row.courses.find. So I'm going to throw a debugger here and figure out why that's broken. Row looks like this. Courses is undefined. That probably our parent row was wrong then. Parent row is an array of. So no, we don't want it to be an array. We want the parent row to be. That's what we messed up here. Our row should be the object representing the row, not an array of rows. So that might fix it for us. Might also not. Parent row dot courses dot map. Parent row courses dot map is not a function. I'm just going to console log out what we're getting as this parent row argument to our function here. And what do we have? It's an object. Excuse me. It's an object that contains courses, and it is complaining about parent row.courses.map not being a function. Courses is an object, which is kind of weird. Yep, we need to wrap that in an array. Alright, so we got through a couple levels of recursion. Let's just hit play here. Alright, so now we're back to square one, except we have our rows as an object, and now we can kind of add some metadata to these rows. So let's go through, and for each of our rows, just as an example, I mean, we can derive the length from the length of the courses array on the row. We're going to add a length property and that's going to be r.courses.length. And we're going to print that out for each row right where we do the index. We're going to print out length. Yeah. And then let's see if that works. Cool, so we've got the lengths now. So now we know we need to split this off into at least a grid of 9. Right now we have these 9 independently floating nodes in here. I'm thinking about making these table cells. You know, to get an example of how this works, we can go take a look at the, there's a JavaScript library out there that I saw that looked good. Oh, it's for jQuery. And I kind of just want to poke around real quick. We might not find anything, but there's a chance we can find out some of the logic of how this is laid out. In fact, I mean, if we went to the demo, yes, I would. So this orgchart.js is a working example of what I want to build. Let's see here. And it builds something like this. And if we look at see, this is kind of how our course data is set up and coming from the API. And it arranges it in this nice org chart here. But how? I'm trying to figure out the structure of how this works. Let's see. First of all, just expand this a little bit. No, it's not going to work, is it? Okay, so now we can still see. I'm going to put this below. Yeah, sounds great. I just want to see how is this organized. Okay, so it looks like each row here is a table cell. Yeah, and you've got our table cell. Let's see. So this is a table right here around the whole thing. And then you got a table row for the first row. You got table row for the first row's lines, another one for the first row's lines, and then you've got a table row for the following nodes. Okay, and then that final row, which is called nodes, where's that first one go? Okay. Interesting. So the final row has all the remaining nodes, and then it recursively creates another one. So call span, this has a call span of 2, and so does this one. I want to know what a call span is. So I thought it was the number of TDs that would table cells it would take up. Yeah, so call span means this has a call span of 1 by default each cell, and then a call span of 2 takes up 2 cells. So I don't know how this one. This is a call span of 2. Well, this one is also. I don't know what that's all about, but. Yeah, the structure is interesting. So see, we can see the recursion happen here. Lines, lines, nodes, and then you go into the nodes, and you see lines, lines, nodes. And I think we probably this one doesn't get it because it's only one node. Yeah. Let's see. How do we print out our first row? So the first row, the whole thing is in a table. First of all. Wild. Let's see something simpler. Using the UL data source, using local data source. This is more like what the structure we have. Except there's no recursion here. See if we can't get something just like this showing up. Okay, so it starts with a table, and then you'd have two tables for lines. The first table has a call span of 16, and then each of these has a call span of 2. And then the nodes are centered. Is that how? With the text align being centered, probably. Or something. Nope. How does this guy get centered? Position is relative. Top left. Okay. So we have, let's see, where did this go? This guy's got 8 different nodes in his setup here. We've got 9 in our largest one. So I think we're going to make our grid double that for 18. This one's got 8 and the grid is 16. Although I'm not sure that it matters for this example for the top row, but we'll see. One second, guys. Yeah, you know what? We might just try and print this out. Well, no. Somehow the top node's got to know about the child node count, vice versa. Let's start. So we've got, these are our like flat rows, we'll call them. Flat rows. And our org chart will take. Okay. And then I think we're going to start playing around with the recursive. Templating this out recursively because that's what it looks like the other node library did, or the other JavaScript library. Let's see what else. Let's see what the source code looks like in here. See, it's got different orientations. That's pretty cool. I bet the source code for this is pretty gnarly, but we'll find out. Let's see how many lines is it. It's not too bad. 1700. It's got a bunch of events. I want to see what happens when we. Let's see what the examples do. I guess we can clone this. So I'm cloning this other code base so I can use it as an example for what we're working on. It's just going to be easier to look through in a proper IDE like a WebStorm. And that's right here. And I think maybe demos in here. So we can take a look at this local data source demo that we were looking at, I think. Source is bundle. Yeah, so to use this thing, we call a new org chart. You give it a container and a data source and a depth. Oh, that's interesting. You supply the depth. Well, I want to see what this depth is used for, I'm sure. Multiple layers. Wow, this is intense. Node content depth. Interesting. And the UL data source, the unordered list data source, this one doesn't have depth. Okay, that's interesting. So yeah, so when we create this org chart through the constructor, the options are here. And I wanted to see what the depth thing does. Okay, it's called ops. We rename options to ops, it looks like, at some point in time. Is hidden, slide up, plus minus. It looks like that doesn't do as much as we thought it might. Dataset, JSON, stringify ops. So this build hierarchy, what does this do? That equals this, ops equals options, node wrapper. Child nodes, node data.children. Okay, so this is kind of like our classes. These are the children would be the prerequisites. So if there is a nested structure, if it's vertical, append to, otherwise document.createElementTable. And document is probably, I don't know what document it is. Okay, so it saves the created element in this node wrapper. Okay, and then appended to, okay, and it passes where to put everything into. So it is building this out recursively. Node data, it needs to know level. So is vertical node ops.vertical depth and level plus 1. Interesting. This might be an option to look at. Tend to this create node. Yeah, node data level. What does this create node do? It's going to return a promise. a node in it. It's going to create a node, and then it's going to take the DOM element of that node, it looks like. Yeah, it's going to resolve this, and the node div is, see, it's so complicated because it's got all these drag events. I mean, we could get rid of all this stuff if we wanted to, because we don't need it. Number flag substring. Well, it does use most of this, which is wild. Checks to see if these are numbers. Where's flags coming from? Flags equals node data dot relationship. Oh. Huh. Append 4 direction arrows or expand collapse. So this checks to see So it annotates each node, like each data representation of the node with some flags. And top edge, node append child top edge. Okay. So by setting this flags object, the first character of the flags, if it's a number, then it creates this this I class with this I element with these classes, and it appends that to the node div. So the node div looks like this. So let's go look for the title. Let's go find that example again. So we're looking, so this is a node div right here, I think, this whole thing. And then in here, you've got one of these, this vertical edge right here. That's what we're seeing, I think, at bottom edge. Let's see where that comes from. See, if we've set this flag here at the third character, if it's a number, then it creates a bottom edge. I don't know, so what I'm saying is that this gets created recursively. Let's see, I kind of want to do this just without the lines. Try doing this. So let's go back to our code base now that we've kind of taken a look at how some of this works. So it sets flags on the nodes beforehand. Probably when it's building things. No. Let flags equals node data dot relationship, or there we go, attach relations right here. If data children, okay, check our code base, see what we can do. So we've got these flat rows, and then our larger structure is or our data starts in a recursive format, like the format taken, or like this format here. So we can use that. I think what we want to do is just map this I think, let's see, something like this, tree rows or something, recursive rows, and we can take each course prerequisite, and I think we need to make a little helper function called map to recursive, and that would take a course, and all we need to do is copy the course and just add children, and that would be course.prerequisites expanded. Yeah. There we go. So it's a map, and then you want to map each of those to prerequisites to this same function. So it's going to go through each level and just set the children to, all it's going to do is rename this field prerequisite, or not rename, but copy this field prerequisites expanded over to children. And that should be all that we need to do to make this usable here. We just don't want to have to use the word prerequisite inside of our org chart, because we're going to try and use this for other things eventually, maybe. So let's see if this works. I just want to map our recursive rows, our console log out our recursive rows, make sure that's still working. Children right here, and then children, yeah. All right, so let's try and print out org chart recursive rows, and then so we're going to kind of create a new org chart element here, because I want to try, we need to try both the recursive way and the flat way. The flat way seems nicer and more manageable in the long run, but I don't know. This guy did a recursive. Maybe it's the way to do it. I don't know. Alright, so we have our recursive rows here, and we're going to have to print them recursively. Recursive node, and that's going to take a node, or no, sorry, row. These aren't even really rows. This is like a tree, but we'll see. We're going to map it's going to be recursive rows dot map render recursive row, and then for each of these this isn't really going to be a row anymore. Let's what have we done here? I'm going to wrap that in a div. And so for each of our row courses, we're going to render an org chart node. Row.course courses. No. So this is where it's it's different. So our recursive rows are, let's see. What does that other code base call this? Let's go to example, and they call just the data, they call it data. I think we can call it tree. And we'll call it tree. Trees have branches which have children. I think tree is better than row for this recursive run we're giving it. So it would be tree. So first we'd render the first element of the tree, and then we would map the tree.children. Right? Render children. And then, yeah, so the children are each going to be a course. And so that node is going to be a course, but really we're calling them nodes here. Row dot courses. We don't have this. What we have is a node dot children dot map. Okay, yeah, we want to, for each of the children, we want to render the children. And for, I think I don't know, maybe add this, and then I don't know, let's see. Let's see if this even renders here. Cannot read property map undefined, so tree.children. What are we sending there? Okay, yeah, we're sending this as an array, which we don't need to. Is that right? Yeah, maybe. Yeah, I think this needs to be. Course prerequisites 0. There we go. Yeah, this is okay. Whoa. So this is different, huh? Let's take a look at what this looks like. So our first div has this finance 307, which requires finance 301, which requires 201, and it also requires 202, which requires 201. And our honors 125, which is also required by the finance 301, is required by honors 124. So now we have this recursive structure like the other library has. But now I need to kind of figure out how to organize this. Yeah, so we have, so this is our flat org chart, and then this one is recursive. I just don't know how. Let's take another look at the HTML of this charting library. Which props to this guy, or these guys. This library, it works really well. It's sweet. But I guess what we do is we throw the a table in here, and I want to see how they derive this call span, sort of. I I want to know if that's dynamic or if that's, like, where is that call span coming from? Okay. Data.length times 2. Build child node. Data is no data.children. So it is figuring out the call span based on the children. And then append to query selector TD. I don't know. Let's start using tables here, maybe. No, not really. We don't need to do that, do we? Maybe we just should have just start drawing lines around our children groups. Child group, and then I'm just going to go into our CSS here, put a light border around it, just so we can see. Yeah, there we go. I think we need a little margin around it too, maybe. Yep. Okay. So now, how do we structure this? This is kind of cool. So, I mean, this is almost readable. This is kind of recreating just this unordered list here format, just using DOM elements. Another thing I noticed is we don't have our original element. We forgot to add that in the beginning, so right? Oh yeah, we're doing that when we're actually templating this out. Parent equals and I think what I want to do is render the parent. Maybe we don't need to do this. Maybe we just render children on the tree. Yeah, and there's our 480 at the top of the chain here, so that's right. Well, we're rendering our data recursively, however, it's not lining up. So we need to figure out what we do to line it up. Well, we know we want the first one to be in the center. What causes this div to stick in the center? Okay. Okay, so text align center on the table cell that contained in. So let's make this a table. Yep. And we're going to make this whole thing, sorry, a table row with a table cell in it. And, well, let's see what this looks like, I guess, first of all. This is actually looking a little better. And then let's center the text in our node cells. Okay. We're starting to look a little better. So we have this, and then our second row, I'm going to skip the lines. Let's figure out how that first row so this table, okay, there's not another table being created yet. So the children are added to a row. For instance, so they're done, oops. The children would go in something like that, called nodes, and then they would have their own deal here. Each children would have a table. All right, getting more interesting, certainly. Let's see. So the children's call span is derived, or the parents' call span is derived by the children. So let's just try setting this call span. Oh no, we map each of the children. Is that how it works? I think so. Yeah. The call span is derived based on the children data length, I think. Let's see. Wait, how does this one look? So this one, this has a, sorry, not that one. I don't care about the lines for now. This top TR, the TD has a call span of 4. Children each have 2. Let's just try doing call span 6 here. Sorry, each child gets a call span of 2. do this again? Let's see. So I think we want to, this call span is derived by the, somehow as a function of like the number of children and, yeah, I think that's it. Maybe the number of parents. So I want to, let's just make this first call span 6. Let's forget about the recursion for now and make the second ones each 2. Okay, so we need to do call span 2. Let's see how this looks. Oh ho ho! This is looking a lot like what we want it to in the end. I don't know if it's quite there. Maybe it is. But you can see Finance 480 right here at the top, and then you've got Finance 307, Finance 307. Is that right? I don't know if that is right. Where's our numbers? No, 303 and 307. Something's a little wonky here. Oh, yeah. Finance 307's right there. No.children.map. We're getting there, though. This is certainly more like what we want. If you look, you can see honors 125 is required by 124, or sorry, requires 124. Finance 301 requires 201. I wonder why this is printing out 3 times. It's so for each child, oh, that's probably it. We don't need to do that 3 times. We just need to do render children child here. Oh yeah, there's our structure, guys. Look at that. So in about 2 hours, we pretty much got it to where we want to be. I guess we spent a lot of time trying to build this flat structure, and it didn't really work out for building this tree because it's just it's a recursive structure by nature, and I guess that I'm gonna make sense. That doesn't work that well. So I think the only thing we need to do now is make that call span dynamic, because obviously this these ones aren't quite right. Let's see what this looks like here. But I mean, this is close. We're very close now, and I think our library is quite a bit simpler than the other org chart library, even though that one's got a lot more functionality. Let's see. And we have to do some styling on this to make this right as well. Okay, let's see. We need what do we need? We need these 3 to all be on the same line somehow. How do we get that? So this column, vertical line top kind of does that for us. We did that on, what do we do? Is that on table cell? So let's try adding that to all of our table cells. And that sort of does the trick there as far as lining everything up the way we need it exactly. So I'm going to call, are these node cells here? Where is that? Let's see. I'm going to make all of these vertical line top. I think I might just open source this library. I don't think I've ever really open sourced anything before, but if I can make the, if we can make this nice and easy to use, which I think is already pretty easy to use, and we can build an example right now just to show you how easy it is to use. But this, we used our course data, and it seems to work just fine. So what we can do is we can get rid of the, maybe we'll leave the border around for now. I think maybe if we can make these fixed width. Oh yeah, look at that. That's a bit big though. Are they already the same width everywhere? They kind of. I just want them to be wide enough so that they don't line break. We're going to make each of our nodes 100 pixels in width. And we need to center, we need to do something about the centering. So this is 130 wide or 160 wide, and this is 190 wide, and this is 190 wide. So we need to make sure these widths are the same, I guess. So even though yeah, let's see what if we did width 33% there. I don't know, that's a little funky, I guess, but maybe we'll worry about that later. We also, I mean, we're going to need to draw lines between things, probably. What else? Yeah, I want to just real quick reproduce the org chart shown in the demo of this other library, just to make sure it's nice and easy to use. So our structure looks like this. I'm going to open this up side by side. Let me make sure real quick you can see that in my video mixing software. If I can find it. There we go. Okay, so you can't quite see it. I'm just going to bring that down a little bit there. There you go. So now you guys can see what we're going to be reproducing. We can create another, let's create a new org chart structure. Const, and we'll create an org chart structure called, I don't know, these look like professors or something, I don't know, or workplace org chart, maybe. And that is going to be a tree. I think another thing, so let's just build our tree out really quick and I'll show you what we're going to do as far as making it so we can either render one of these guys or render a course like we've been doing, and so that they both work for the same with the same library that we're building here. So the workplace org chart is going to start. How does this start? What is this supposed to look like? Meow. Has children, and the children are Te Hua, who has no children, nobody under him, and Hey, who has some children, one is named Peng Peng, and that has no children, and the other is named Zhang Zhang. And he has no children. We've reached the bottom of our recursion here. So this is the structure of this org chart that we're seeing here in this example. And it's really simple to build this structure out. So I want to feed this to, so I'm going to put another org chart recursive in here, and we're going to use this workplace org chart as the tree here. And if we look, we can see pretty much everything is going to be fine up until the point where we get to our node. And I think what we should do is, instead of, I think we should supply the node component into here. See that? And we're going to supply the component used to render the nodes. So that would be org chart node. And I want to call that, I want to rename that, because this node is actually, it's actually specific to our course. Or sorry, this would go with our original tree. It's specific to our course structure. It prints out the subject and the course. Let's go back to that. Where's that? So the node is actually a course. And if we look at our, let's see, calling of it. So now we can actually pass that component in, and I want to call this, we'll call that node instead. That actually makes more sense. We're gonna call that node. And if we wanted to do some like vanity variable to make that more specific, we could rename course to node here or something. But we don't need to for this example, I think. And we're going to create a new node component called workplace org chart node. And we can create that, we'll just put it up here for now. And it's going to adhere to the same interface where it takes a node in. And but this node just prints out node.name, and we did that wrong there. So, and we use node.name because that's the text of our node here. So let's see how this looks. If it hates us, cannot read property subject of undefined. So we didn't quite get it right here in our course org chart. So let's take a look. So we're passing this node component into there. Node is node. Cannot read property subject of undefined. You know what? I bet it's yeah, it's right here. That needs to be node. This is from our old chart. Our new chart's probably working. This is our old chart that was having troubles. Expected a string or a class function, but got undefined. Course controller on line 379. Saying node is undefined. Render children with the tree. Org chart recursive. Did we forget to put children in here somewhere? Something? Let's see. I'm going to comment out our course org chart for now. We're going to debug it with our existing org chart. Let's see. Check your code at course controller 379. So we're going and we're passing in our tree. Tree right there. Node component is our second argument, except the spacing is wrong on that, so I don't know. That might make a difference. Let's see. Maybe we should call that node component. Yeah, there we go. So that was what was undefined. And look, it printed out our org chart. Let's compare it side by side with this other org chart. We need a little bit more space here. So now we can see, let's actually hide that flat org chart. I think we're going to probably get rid of it. I think it's pretty useless. It was an interesting exercise. Maybe we'll save it somewhere. And then I'm going to also enable our course org chart, and I want to see that they both work at the same time. And they do. Look, so the same recursive org chart that we built for React renders both the classes that we supplied to it, which have a different format than the professors or whatever. Let's give this a title here. Fine. What was it? 408, 480 prerequisites. And this one we'll call Samsung org chart. This is complaining. We need to pass that title in there. Let's see what this looks like. Make this ONH2. And let's get rid of where is this coming from? Get rid of that. Oh, that's where we're doing. What the yeah. Yeah, there we go. So now we've got our prerequisites. We've got a chart for our prerequisites. Right here, we've got a chart for our Samsung org chart right here. And everything looks good, honestly. I mean, I'm happy with this as a version 1. We need to draw lines in between things, and if we can line things up, that'd be great too. I think we're going to be able to. I'm going to open source this library just because it seems to have a pretty simple interface. I mean, we expanded that. We added that new org chart in minutes. The interface seems to make sense to me. I think while we're here, I'm gonna create a new file here called org chart recursive. Or no, sorry. Whoops. Delete that. No. We're gonna be safe here and not delete the whole thing. Org chart flat. And I'm gonna copy all that. I'm going to copy all of the flat bit here out of here. And yeah, see, we never ended up using, unfortunately, this bit. I think that's going to be useful maybe later on for another project I'm working on, but not for this. I just want to throw this stuff in there, make sure everything compiles. It seems to be pretty snappy as far as rendering speed goes, which is good. Yeah, we don't need this. Don't need the flat rows anymore. Don't need any componented mount. Just see how fast this renders. It's pretty quick. It's going to be fast in production. I mean, or just to use, it's fast. What else could we do? So I mean, since I mean, it would be really easy to pass like click handlers and things like that to these nodes, or just as part of these nodes. Like if we wanted to make our let's edit this workplace node real quick. Let's add an on-click alert. My name is node.name. And let's just see how easy. Oh, wait a second. We're not clicking. Maybe we need to thunk that. Exit. So now if I click on Bo Meow, hey, hi, my name is Bo Meow. Hi, my name is Lala. So we can add functionality like that really easy just by implementing these nodes. And so really all you have to do is build out a structure that looks like this with children. Another thing I want to do is get rid of the dependency on this array of children. So let's see what happens if I delete children here. It's broken, right? Because it's looking for that array of children. Well, what I want to do, let's see, so we call node children here. Is that the only place we call children? I want to do node.children or an empty array here, so that if it doesn't find the children, it tries to map over an empty array, which obviously is going to yield nothing. Now we can delete these useless children lines here in our data structure, making it even simpler. That should still work now, I guess. Yeah. So that's pretty cool, huh? This is a really simple structure to create this org chart. And we're going to add lines and things like that to this, guys. I think you can kind of see how that would be done. I guess we would have another row right here, maybe, and then put two divs inside of it of equal width, and then draw a line up the middle of them or something like that to draw the lines here. But I mean, this gets the point across. So for this part, I think we're done making our org charts better. Get rid of that. What else can we do to clean this up real quick? We don't use that, I think. Although that might affect things. It doesn't. Stocks.css, we don't use that. Do we use? We don't use component because all our components are state. Component is not. We do use components. Let's see what else. Not really. Rows. Just trying to find things to clean up. I mean, it looks like we've done a pretty good job. I'm really happy with where we are at this stage. Let me zoom out to show you guys the final result. I think maybe I need to come down a little bit for you guys to see. But yeah, I mean, you can see 480 clearly depends on three classes: Finance 307, Finance 303, and Finance 345. Each of those classes depends on Finance 301. And then you can see the structure for Finance 301. 301 relies on Accounting 201, Accounting 202, and Honors 125. Accounting 202 relies on 201, and Honors 125 relies on Honors 124. And then the Samsung org chart was nice and easy to render too. So we did it, guys. We actually did create a pretty good org chart in about 2.5 hours total. Thanks for watching. This is going to be open sourced. I think maybe I'll stream open sourcing the thing. Probably eventually we'll enhance it using like by drawing lines in between the cells. Maybe you guys could leave some comments below on what you think we should do next. Thanks for watching, guys. As always, it's really awesome to see people watching these videos, and hopefully you guys are learning from them. I'd like to hear about your experience watching the videos. If you guys have any feedback or comments, please leave those below. As always, subscribe. Getting that subscription number up is always cool. It doesn't make me any money, but it's fun. Have a great day, guys. See you later.